And let's move to the page number 2. The first one is type of behaviors, right? Types of behaviors, right? Behavior in chemical reactions. Types of behavior in chemical reactions. Here normally I divide chemical reactions into 2 types according to their behaviors. The first one is thermochemical behavior. Thermochemical behavior. Thermochemical behavior. And the other one is here kinetic behavior. Thermochemical behavior and kinetic behavior. So in this unit we learn about thermochemical behavior of the chemical reactions. Thermochemical behavior of the chemical reactions. So I will explain the thermochemical behavior and the kinetic behavior. So normally thermochemical behavior goes with the potential energy. This one goes with the potential energy. This goes with the potential energy, and this goes with the kinetic energy. And this goes with the kinetic energy. So when it comes to the potential energy, for O level we use mgh, but here we consider about the potential energy of the atoms and molecules. So those are more smaller units when it comes to atoms and molecules. So when the atoms and molecules, they change their potential energy when they form bonds. It means bond formation, bond breaking, and because of the intermolecular interaction. Intermolecular interactions. Potential energy varies when they form bonds, when they break bonds, when they form intermolecular interactions, likewise. Although when the type of the intermolecular interactions changes, their potential energy change. And when it comes to the kinetic energy, right, kinetic behavior, the kinetic behavior will depend on the kinetic energies. But in this unit, we do not discuss about the kinetic behavior. In unit 11, we will learn about the kinetic energy. Therefore, right, so you can write down these things in the place I have given. So there is a place to write down a box. So you can draw this one in that box. And also in this one, intermolecular interactions. So when it comes to the thermochemical behavior, we measure the energy. So energy change when bond formation, bond breaking, and because of the intermolecular interactions they form. And this goes with the kinetic behavior, and that is related with the kinetic energy. We learned that one in unit number 11, right? So you can write down these things in the books. And after you write down these things, I will remove this one, right? So after this one, intermolecular interactions, you can write down after this one, right? After this one, I'll get that part here, right? That part here, intermolecular interactions. What we measure is, we measure the energy change, right? Energy change. So how we measure the energy change? We measure the temperature difference. Temperature change. Temperature increasement or temperature decreasement. By measuring temperature increasement or temperature decreasement, we calculate the thermal energy by using delta Q sum is equal mc delta T, and then we get the energy. So by using this equation, we measure the energy change. So that is how we measure the energy change in thermochemical behavior. Right. So what are the types of behavior in chemical reactions? There were mainly two types. One is thermochemical behavior. The other one is kinetic behavior. So kinetic behavior related with the kinetic energy. We learned that part in unit number 11, chemical kinetics. For this unit, we learn about the thermochemical behavior. That is related with the potential energy. The potential energy of the molecules and atoms will depend on the bond formation, bond breaking, and intermolecular interactions. So how we measure the potential energy? We measure the energy change. So how we measure the energy change? We measure the temperature change. It means we can measure the temperature increasement or temperature decreasement. And then by using the equation delta Q is equal mc delta theta, we can calculate the amount of energy released or absorbed, and so we can calculate the energy change likewise. So this is the basic things. So you can write down these things within the books. And then let's move to the other factor. Let's move to the other factor. In note I have given, so you can read the note. In chemical reactions, two main types of behavior can be observed. Thermochemical behavior. This refers to the change in the potential energy of the reacting species during a chemical reaction. The other one is the kinetic behavior. This refers to the change in kinetic energy, movement energy of the reacting species. Right? In this lesson, we will focus on thermochemical, otherwise potential energy behavior. That is the note. So you can write all the things within the books. I will remove this one. So you can stop the video and write down the note. So I will teach, right? That's the second topic. Write down the second topic. Energy changes in chemical reactions. Energy changes in chemical reactions. So when it comes to the energy changes, right, there can be three types of energy changes in chemical reaction. Three types of energy changes in chemical reactions. First one is reaction that absorb energy. Normally what is we consider as a reaction? We consider here there will be reactants, and it will convert to products. Reactants that will convert to product. So this process we call as a reaction. In some reaction, they will absorb energy. So if we consider the energy of the reactant, energy of the reactants, energy of the reactant and energy of the products, energy of the product, right? So when the reactant has some energy, and when the reaction occurs, if it absorbs some energy, that will get inside the product, right? That will be inside the product. Therefore, when the reactant absorbs some energy, they will produce product. It means energy of the reactant is less than the energy of the product. So this is the first type. when the reaction occurs, they will absorb energy. So let's go to the note. The first one, right? Reactions that absorb energy, we call endothermic. So don't consider about the name. I'll teach about the endothermic and exothermic later, right? The reactions that absorb energy, after the reactions, the energy of the system is higher than the before, right? The reactant, they will absorb energy and produce product. Therefore, energy of the reactant is less than the energy of the product. Product has more energy since the reaction absorbs some energy. Right? Example, energy is taken in from the surrounding. Energy is taken in from the surrounding. We get energy from the surrounding and our energy will increase. Right? And let's move to the second one. Reaction that release energy, we call exothermic. So we will learn in later. Reaction that release energy, right? So what happens if the reaction release energy? Now this is absorb energy, and the reaction, now what happens? It will release energy. Now this one, it will release energy. It will release energy. So this type of reaction, what happens? Initially there was some energy in the reactant. When the reaction occurs, reactant has removed some amount of energy and it will form product. Therefore, in that case, the second type, right? Second one, the release energy. Therefore, the reactant has more energy. Energy of the reactant is higher than energy of the product. So what happens there? Now reactant has some energy, it has released some energy and it will produce product. So in that case, energy of the reactant is higher than the energy of the product. So that is what happens. And that is the second type. So when we go to the third one, right, now you can fill that this part within the box. You can fill this part within the box. Now box එක ඇතුලේ දාගන්න. So let's move to the third one, third page. තුන්වෙනි එකට. Third one, right? Reactions with no energy change. Reactions with no energy change. Third one. මෙයාව දාගන්න. And then let's move to the third one. Third one, right? Energy absorb. Absorb, right? Absorb energy. So when it comes to the third one, no energy absorb. Energy absorb, no energy release. No energy release. In that case, what happens? Energy of the reactant is equal energy of the product. Third type. The box එකක් තියෙනවා. Third one එක page number 3 වල. Third number 3, reactions with no energy change. The energy before and after the reaction is same. No energy is absorbed or released. No energy is absorbed or released. Now reactant, no energy absorbed, no energy released, product will form. In that case, energy of the reactant equals to the energy of the product. So this is the third type. Third type. So that part is over and let's move to the other part. That part is over. So let's move to the other part. Energy and stability of the species. Write down the topic. Energy and stability. Energy and stability of species. Energy and stability of species. So this is something that I have teach you at the beginning of your class. Energy and the stability. So if we go back to O level, so what we learn, when MgH increase, right, our stability will decrease. So if we consider a tree, right? If we consider a tree, so what happens when we climb that tree? So when we climb that tree, our MgH will increase. So that is normally what happens. So when we know, when we climb that tree, right? So we are here now at the point where MgH that is 0. Now we have more stability. So when we trying to get some fruit, right? So now we are here, right? We are here. Now what happens when we climb there? Our MgH will increase. In that case, the stability will decrease. When MgH increase, our stability will decrease, right? It means here we also consider about the potential energy of the atoms and the molecules. We consider about the potential energy of the atom and the molecules. When the potential energy increase, stability decrease. But here we do not use the word potential. Only we use the word energy, right? But we have to keep in mind. So we are talking here about the potential energy. Therefore, when potential energy increase, stability decrease. But here we do not use the word potential. So I will use only the energy. So here when energy, right? When energy increase, what happens to the stability? Right? Stability decrease. When energy increase, stability decrease. When energy decrease, stability increase. Now here I have put a box there. So what you can write down there, right? Energy inversely proportional to the stability. Energy is inversely proportional to the stability. Energy is inversely proportional to the stability. You can write this one. Right. So let's move to the next topic. The next one is basic terms in thermochemistry and thermodynamics. Write down the topic. Basic terms in thermochemistry. Thermochemistry and thermodynamics. The basic terms in thermochemistry and thermodynamics. Basic terms in thermochemistry and thermodynamics. Basic terms in thermochemistry and thermodynamics. So I'll remove the topic. And then let's move to the basic terms. Initially there are three terms. One is system. The other one is surrounding. The other one is surrounding. The third one is boundary. System, surrounding and boundary. System, surrounding and boundary. So we have to know the definition of each word. System, surrounding and boundary. So I'll explain this one, right? So let's consider a beaker. Right? Let's consider a beaker. Now we use a beaker. and we are going to do some experiment using that beaker. So we include some chemicals into that beaker. Right? Now this will be our system. The bee inside the beaker. That is our system. So now what is the system? System is the part which we consider to do a reaction, right? Something like that. That is what system, right? So I have given some kind of thing about the system, so you can read it. This is a part we are studying in a specific experiment or a chemical reaction. So this is the part that we choose from the universe. To do a reaction or to do an experiment, right? So this is the part we choose from the universe to do a reaction or to do an experiment. So that is what? A system. Now here if we use a beaker, inside the beaker is our system. Inside the beaker is our system. Inside the beaker is our system. So the glass wall of the beaker, that is the boundary. That is the boundary. So other than system, all the other part which interact with the system, we call surrounding. We call surrounding. And all the other part except system, we call environment. We call all the other part except for the system that we choose as environment. And the environment close to the system, we call surrounding. Right? We call surrounding. Now this one is our system. So this is our system. Right? So inside this one, we have our system. Inside that one, you can write system. Right? Now here in the page number 3, let's read. Right? System. This is the part we are studying in a specific experiment or chemical reaction. It can be anything we focus on, like a chemical inside a flask. It can be like this. And then surrounding. Everything outside the system that can interact with it. The surrounding is the everything outside that can interact with the system. And then what is boundary? The line or surface that separates the system from its surrounding. A line or the wall which separate the system from its surrounding. It can be either wall of a container, or it can be an imaginary one. It can be a wall of the container or something imaginary. So let's move to the page number 4. Let's move to the page number 4, and there is space. There is a box. So what you can do, you can divide the box. Right? So what you can do, so we remove this one. Right? Now hope you get the idea. So inside the box, you can write down something, a circle, and then write down this is our system. Right? This is our system, and this one, the red circle, that is our boundary. This is our boundary. This is the boundary. This is our boundary. And then what is all the other thing? That is surrounding. All the other thing is surrounding, which interact with the system. That is called surrounding. Within that box, you can draw this one. Surrounding, system, and this is the boundary. Surrounding, system, and this is the boundary. Right? So that part is over. Now that is also over. And then let's move to the other one. The other topic. Okay. Now in page number 4, types of systems. It says types of systems. Types of systems. So we have learned the type of system. We have learned about type of system. Basically, there are 3 types of systems that we need to learn. 3 types of systems. We have to learn about 3 types of systems. Write down the topic, types of systems. And then we have to learn about 3 types of systems. We have to learn about 3 types of systems. Right? So I'll explain by considering a beaker. Right? So here we have a beaker. Which is open beaker. Now this is open, and we put some chemical over here inside to the beaker. We put some chemical, a solvent maybe, and then if we get another beaker, right, and then we close the beaker, right? We close the beaker, Now we close that beaker, right? Using some cover, we close the beaker, right? And then we fill some chemicals into that. We fill some chemicals into that, right? And then another beaker which is also closed. Another beaker is also closed. Let's consider another beaker is also closed one. Is also closed. Right? And then we fill some chemical into that one also. So what you do is you use a vacuum container, right, to cover that one, and here you use this cover as thermal insulator. Use their thermal insulator. And here this one is vacuum container. Thermal insulator and vacuum container. Right. Now these are three types of containers. One is open. Right? One is open. Since because this one is open, now we can put some matter inside to the container, and also we can remove matter from the system, and also energy can transfer inside to the system, and also energy can go outside to the from the system, right? So in open system, the matter can come and matter can go from the system, and also energy can come inside, and also energy can go outside from the system. So that is open system. So one type is open system. So when we consider open system, right, now this is our system. So open system, matter also can transfer, right, through the system, and also energy can transfer through the system. An open system means the systems which matter and energy can transfer through the system. Those we call as open system. So that is same for this one, open system. So let's go to the page number 4. Types of system, open system. Open systems are both energy like heat and matter like solids, liquid or gases can move in and out. Example, open bottle of salt water. So here we can consider a beaker, open system, matter can transfer, energy can transfer, like open beaker. So there is a box. After that one, what you can do, you can divide that one into two, that box, and draw these two. Open system. Draw this one and also draw this one. Open system. So you can draw these two. You can draw these two. You can draw these two. And then I'll remove. So then let's move to the other one. This one is open system. And let's move to the other one, that is closed system. The second one is closed system. Now what happened in the closed system? Now here matter cannot transfer. Come inside or go outside from the system, but energy still, the energy can transfer. Energy can transfer. Energy can come inside or energy can go outside from the system. So if we draw a picture for that one, right, this is our system. Matter cannot transfer, come inside, or matter cannot go outside from the system, but energy can come inside. Energy can come inside or energy can go outside from the system. So this is closed system. The closed system, only energy can move in and out, no matter. Example, a sealed bottle of liquid where the liquid and vapor are in balance is something like this one. Within the box, so you can, within the box you can draw this one. Second box, you can draw this one. Within the second box, closed system. This is closed system. You can draw this one, right? The closed system. That is closed system. And then I remove the open system. Right? I remove this part. Open system. And then also let's close this one. The closed system. Let's close that one. And then the last one, the final one, we call isolated system. Isolated system. The third one is isolated systems. Isolated systems. So what happens here? What happens here? Because of the vacuum, energy cannot transfer, but energy can transfer through the vacuum by radiation. Therefore, we use thermal insulator beaker, which thermal insulator. The surface is thermal insulator. And then we close that beaker and then we put that beaker inside a vacuum. In that case, energy also cannot transfer through the system. Matter cannot transfer, energy cannot transfer. We call those systems as isolated system. So here this is our system. If the system is isolated but matter cannot transfer, matter cannot come inside to the system, or matter cannot go outside from the system. And also energy cannot go through the system. Energy cannot come inside to the system, or energy cannot go outside the system. This type of system we call isolated system. Right? So last sentence in the page number 4. Isolated system, neither energy nor matter can move in or out. Example, a thermos flask that keeps coffee hot. Right? That is not 100% isolated system. Right? The system like this one, which is thermal insulator and keep inside the vacuum container, we can consider as isolated system. Through that system, matter or energy cannot transfer. In the page number 5, there is a place, the box. So you can draw this one, this part and this part. Divide the box into 2 and draw this one, and also you can draw this one. Right? So that is it. So that part is over. And then now we have to move to the next part. So let's move to the next part. I remove this one. I will remove. Okay. The next part. What is the next one? Homogeneous and heterogeneous systems. Write down the topic. Homogeneous and heterogeneous systems. homogeneous and heterogeneous systems. Now again there are two types of systems, homogeneous systems and heterogeneous systems. So this is comes like because of the physical state of the matter, like solid, liquid and gases. So these are three physical state of matter. If we consider a system, right? If we consider a system, and within that system, right? Let's consider a beaker which is closed. Consider a beaker which is closed, and then if we put inside this beaker fully, if we fill this beaker using a mixture of water and ethanol, C2H5OH mixture, H2 and C2H5OH mixture, right? Now here inside the beaker, ethanol is also a liquid, water is also a liquid, and this is the same phase mixture, liquid, we call same phase, and here we use homo instead of same. Then homo means same, same phase mean homogeneous, homogeneous systems, then same phase systems. Homogeneous systems mean same phase system. It's like water ethanol mixture. Water is a liquid, ethanol is liquid. Inside that system we call homogeneous system. So what will happen if there is heterogeneous system, right? Now there is a space, homogeneous system, everything in the system, everything in the same physical state. Everything inside the system is in same physical state like this one. So within that box you can draw this one. Within that box you can draw this one. Within that box, draw this one. Within that box. Example, air, OL, right? Air. So we can consider air. That is homogeneous mixture. That is air means homogeneous system. Or we can consider alcohol water mixture. That is homogeneous system. And then we remove this one, and then that is homogeneous. And the system, if the system is heterogeneous, the things inside the system should need to acquire two different phases. If we consider a flavored drink bottle, right? So here I'll draw that one, flavored drink bottle, right? It goes like this, and here, okay, it goes like this, okay, right? Now it goes like this one. Now this is something, a flavored drink bottle. It closed. Normally they closed using a cover. It is closed. Closed. Here in this flavored drink bottle, up to some point drink is there. Up to some point drink is there. Now here drink is liquid, and here a little bit amount of gas is there. Now this kind of system is heterogeneous system. It means the things inside the system belongs to two phases, two physical phases, liquid phase and gas phase. It's like two different physical states. We call heterogeneous system. Hetero mean different. Hetero mean different. Hetero mean different. Different physical phases. Gas and liquid. So this is heterogeneous system. So heterogeneous system in page number 5. The system contains parts in different physical states. Example write down. Example write down. Flavored drink bottle. Flavored drink bottle. Flavored drink bottle, and draw this one. Flavored drink bottle which is in equilibrium with the liquid phase and the gaseous phase. That is example. Flavored drink bottle which is the liquid is in equilibrium with the gaseous phase. So this is example. So within that box you can draw this one. Gas and liquid, different phases, heterogeneous system. So this is heterogeneous system. Right. And then page number 5, properties of a system. Properties of a system. Properties of a system. Properties of a system. Here we consider mainly about two properties. The one is microscopic properties. Microscopic properties. The other one is macroscopic properties. Microscopic properties and macroscopic properties. So these are two things that we know already. Macroscopic properties. Macroscopic properties mean that we can observe by our naked eye, right? Which the properties that we can observe from our naked eye, or we can touch them and feel them. Likewise, properties we call macroscopic properties. So we can touch a person and we can say, yeah, you are a cool person, right? Or you are a hot person. Or we can see a person and we can say like you are a white person, or you are beautiful, you are ugly, so you are hot. Likewise, we can tell something. Those are macroscopic properties. But when it comes to the microscopic properties, so we cannot say that you are a good person, inside you are a good person. We don't know that one. So we have to go to the inside of that person to check about the microscopic properties. So when it comes to the chemicals, so we need to study about the properties of the atoms or the molecules to know about the microscopic properties. So then what are the macroscopic properties of atoms and molecules? So when atoms and molecule combines, so we can tell their properties from the outside. If we consider a system like the previous system that we consider, a bottle, flavored drink bottle, that system, right? So what we can tell about the system, the macroscopic properties are color of the system, that is macroscopic property, and then the color, and then the amount we can say, and when we can touch it and tell the temperature of the system, that is also macroscopic property, right? So those are macroscopic property. What are the microscopic property? So we cannot, by observing the system, we cannot tell about the velocity of the molecules. We cannot tell that one because we cannot observe by just observing the system from the outside. To measure the velocity of the molecules, we have to go inside to the level of the molecules and to the level of the atoms, and we have to observe the velocity of their velocity. So the velocity is like microscopic property, while the color of the system is a macroscopic property. Now you can understand the things regarding to the microscopic properties. and the things regarding to the macroscopic properties. So let's go to the note. The properties of a system, the microscopic properties, these related to very small things like atoms or molecules. We cannot see them directly. Example, speed or energy of molecules. We cannot see them directly. But when it comes to the macroscopic properties, these are the properties we can measure directly and observe, like temperature, pressure, volume, color, likewise things. So let's move to the last part of the today's lesson. Last part of the today's lesson. So I'll remove this one. So let's remove this part. And then let's go to the last part. Right? The types of macroscopic properties. Now we get the macroscopic properties and we divide that one into two. Write down the topic, types of macroscopic macroscopic properties. There are two types of macroscopic property. One is extensive property. The other one is intensive property. Extensive properties and intensive properties. So I'll explain, right? So you may listen. This is the last part. It will take just 5-10 minutes to explain extensive and intensive properties. This is some kind of important for our lessons than the previous things. Is some kind of important than the previous things. Extensive and intensive properties. Extensive property. So I'll consider a beaker filled with water. A beaker filled with water. And here we get 20 milliliter. And to this one, let's get like 40 milliliter. And to another beaker, we will get 100 milliliter. So the volume is changing. We can observe that one. Right? Volume is changed. We can observe that one. If we measure, like if we think this is water, H2O 20 milliliter, H2O 40 milliliter, and 100 milliliter of H2O. The volume, we can see volume that is changed. And if we are going to measure the mass of each of these samples, so we can say that here mass is M1, the mass is M2, that is greater than M1, and here M3, that is greater than M2. So we can observe that when the volume increase, mass is also increased. The extensive properties are the properties which depend on the size or the amount of the matter in the system. Size or the amount of the matter in the system. Now our matter is water. So we put here 20, 40, 100. So now when we put here 20, that is 20. And here 40, it is 100. So if we measure the mass is different. When the amount of the matter changes, the mass changes. When the amount of the matter changes, volume changes. Therefore, volume and the mass is also extensive property. So what are the extensive properties? The properties which depend on the size or the amount of the matter. So volume and the mass is depend on the amount of the matter. It changes. So therefore it is extensive property. That is extensive property. So what are the intensive property? So if we consider, right? So all of these samples we get from initial sample of water container, H2O. right? If we measure the temperature here, that is T, and we get that one from the initial sample, and here also we get that one, and here we also get that one. So if we measure the temperature of the system, that is T, and if we put a thermometer here, and if we measure the temperature, that should need to also T, and if we measure the temperature by using a thermometer, that should need also it give a T, and here also it should need to give T. Then the temperature does not depend on the size or the amount of the matter. Temperature do not depend on the size or the amount of the matter. Therefore, temperature is intensive property. So what are the intensive property? The property which do not depend on the size or the amount of the matter inside the system. Those are intensive properties. Those are intensive properties. So let's go to the note. Extensive properties depend on the size or the amount of the matter in the system. Examples: mass, volume, total energy, number of moles. Likewise, if you split the system into parts, the extensive property also is split. Remember, here we split that one into some parts. That extensive property also is split. Mass also is split. Volume also is split. So those are extensive properties. So if we move to the intensive properties, do not depend on the size or amount of matter. Do not depend on the size or the amount of matter. Temperature, density, boiling point, color. If you divide the system, these properties stay same. So here temperature remain constant. We divide that one, temperature remain constant. So temperature is intensive property. So those are the basic facts. And there is another sentence regarding intensive property. There is another sentence regarding intensive property. Right? So let's read that one. After that I will explain. Sometimes when we express an extensive property per unit, like per mole or per gram, it becomes an intensive property. Example: volume is extensive, but density, volume per gram, is intensive. So I will explain that one. Now here, if we consider the density of H2O, that is 1 grams per cubic centimeter. The meaning of this one is, the 1 cubic centimeter of H2O is weight 1 gram. Now here, if we get the density of this one, it gives the mass of 1 cubic centimeter. So let's see, this is the volume that occupies 1 cubic centimeter, and mass of this 1 cubic centimeter is the density, that is 1 gram. So here in the sample, the same amount of volume will be considered to get the density. The mass of 1 cubic centimeter, that is again 1 gram. Even though the volume is different, here again we consider that's the 1 cubic centimeter to get the density. The unit volume, the mass of unit volume is density. So here, no matter the volume, total volume, we always get the mass of 1 cubic centimeter to get the density as a unit, grams per cubic centimeter, grams per cubic centimeter, grams per cubic centimeter, right? Grams per cubic centimeter. Here also we consider 1 gram, 1 cubic centimeter to get the mass. So 1 cubic centimeter mass 1 gram, 1 cubic centimeter mass 1 gram, 1 cubic centimeter mass 1 gram. So therefore density become intensive property. So some properties we define for unit volume or unit per unit, it will become intensive property. That is what it says, right? So if we get the volume, right, volume, and if we get the mass, these two are extensive properties. But if we get density, the density become intensive property. If we get the molar volume, that is intensive property, because we get the volume when the volume different, but we consider the volume of 1 mole. Think volume of 1 mole is this much, that is remain constant. Volume of 1 mole, volume of 1 mole, volume of 1 mole, that remain constant. If we get molar mass, that is also constant. Molar mass is also intensive property. The molar mass is carbon 12, molar mass is H2 molar mass of carbon dioxide, that is 44. Those are constant. It do not depend on the size or the mass of the matter. They do not depend. Those are called intensive properties. Extensive properties and intensive properties. So these are the things that we have planned to teach you today. Right? So, and these are some basic things regarding the unit 5. So you can go through the note and the video and you can complete the note. So we will be doing next class, right, starting from the things where we stopped today. So hope you write the note and complete the note. So these are much easy parts, and the unit will become more interesting in future lessons. So hope you may practice these basic things well, right? So we will meet with the next class. See you.